This is another problem in Putnam, and I'm taking up all the linear algebra problems from Putnam. The key inspiration being that linear algebra forms an important part in AI and machine learning. So it's a good idea to solve some of the good problems in machine learning. This actually does not use a lot of matrices and other linear algebra information, but still just compute the determinant of A. Now let A be an n by n matrix, and the ith row and jth column matrix is given by 1 upon of min of ij. And that's something what we'll try to do is get a feel of how this matrix A looks like. So I will start with, let's say, this matrix A is equal to, and we will try to write a big matrix, we don't know how big, and start putting the entry. So let's say we go to the first column, and let's say if it's a 2 by 2, then this entry is going to be 1 upon, and min of 1 is 1, so this is 1 upon 1. And then let's say we have second column in the second row, and this is going to be 1 upon min of 2, and 1 is 1, so this is 1 by 1. And then the second row, this is min of, this is going to be 1 by 1. And then this again is 1 by 2, because min of 2 and 2 is going to be 2. And then we move on to the third row and third column. This is all again going to be 1 by 1, 1 by 1. And this is 3 and 2, the min is 2. And this is 3 and 2, 1 again, 1 upon 2. And this is 3, 3, 1 upon 3. I can continue more. So let's say this is fourth row and fourth column. This is 1. This is between 4 and 2, this is always going to be 2. So this is 1 by 1, this is 1 by 2. Now this is 3 and 4, min is 3. And 4 and 3, min is 1 upon 3, and again 1 by 4. And just one more. And this is 1 by 1, by the way. This is 1 by 1. This is again is 1 by 1, 5 and 2, 1 by 2, and 5 and 3, 1 by 3. And then this is 1 by 4, and here we'll between fifth and fourth. So now this one is fifth row, 1 by 1, 1 by 2, 1 by 3, 1 by 4, and 1 by 5. Let's stop it here and try to visualize this matrix and how it looks like it can continue. And this is important part of your problem solving. Once things are given in a cryptic form, ij, etc., you need to work with real numbers to get a feel of it, and then you parameterize it in terms of ij and whatever, etc. So the key idea here is, I want to make sure everything looks good. If you look at any two row, this row and this row, the only difference is in between these two terms. And for example, in these two matrices, in these two matrices only this. So if I subtract from this one this whole thing, I get a matrix. I'm trying to get a simplification, because if you want to compute the determinant, you want a entries that are mostly zeros as much as possible. So in the last row, from the last row, if I subtract this is row number 5th, and this is 5th, and 4, 3, 2, and 1. Then this entry is going to be 1 by 5 minus 1 by 4 and rest of the entries become 0. And in the same way, if I try to subtract from this row this one, then all entries become 0 except this last two rows. This will become 1 by 4 minus 1 by 3, and this will become 1 upon 3 minus 1 upon 4. And in a similar way, I can go on and write this row, let's say row number 3. From row number 3, I subtract row number 2. So I get 0, 0, and then this becomes 1 upon 2 minus 1 upon 3, and this is 1 upon 2, 1 upon 3, 1 upon 3 minus 1 upon 2, 1 upon 3 minus 1 upon 2. So in the same fashion, this one would become 0, and this one will become 1 upon 2 minus 1 upon 1. And finally, this I can leave as it is. You don't need it there. So if I look at, and if I'm trying to find the determinant, we know that all those leading these things are 0, and therefore it's easy to compute the determinant. The determinant of the whole thing will be multiplied by determinant of this, which in turn is the determinant of this, multiplied by the determinant of this, etc. So they are fitting in a nice space. If I want to write it, so basically this is, for example, this one is going to be minus 1 by 2, and this is minus 1 upon. So if you take it any, so how does this determinant looks like? Determinant of A, how it is going to look like? 1 multiplied by 1 by 2 minus 1 upon 1 multiplied by 1 upon 3 minus 1 upon 2 multiplied by 1 upon 4 minus 1 upon 3, etc., etc., etc. And the last term is going to be 1 upon n minus 1 upon n minus 1. And that's how we will have n terms looking like this. Now, I can write this one as 1 multiplied by, the difference is going to be minus 1 divided by 2 into 1, or I will write it as 1 into 2, 1 into 2, then this multiplied by minus 1 divided by 2 into 3, minus 1 divided by 3 into 4, and so on and so forth, minus 1 divided by n minus 1 into n. So now let's collect all the minus 1 terms. There are n minus 1 terms. So I can write it as minus 1 to the power of n minus 1 divided by. This pattern is a nice pattern, and the way to write it in a simplified form is to collect these things 1, 2, 3 all the way to n minus 1. So I write 1 into 2 into 3 into n minus 1, and then multiply it by 2 into 3 into 4 all the way up to n. And I can just add 1 from my own to make it simpler. So this becomes minus 1 to the power of n minus 1. If you notice it carefully, there is nothing but factorial n minus 1, and this one is factorial n. So in this problem, there are only two things. You don't need to stop somewhere. You need to just start writing something just to get a feel of this thing. And the key idea is to finally visualize as you look from bottom to top that these terms start cancelling out. These and these rows are, if you subtract this thing, it becomes 0. And the same thing, you need to identify this pattern that this becomes 0, and then identify that this pattern becomes 0, and so on and so forth. So all those leading elements, they vanish to 0 if you progressively go on subtracting the alternate rows. So keep looking for more such problems. This problem has a lot of, could be made more complicated. For example, how do you find the inverse of A? And one thing that comes to my mind is, if there is a matrix and if you add one row and one column, how to incrementally find the determinant of that matrix in an efficient way. So try finding the inverse of this matrix. That could be an interesting problem, and there could be more linear algebra problem that I will be keep posting. So thanks for taking a